Measurement of electric current. It is measured using a multimeter used as an ammeter. Why is it called multimeter? Multi for it functions. It has multiple functions, and meter because it's used for measurement. So it is used as an ammeter. It must be connected in series, like one-to-one terminal. One terminal of the ammeter must be connected to one terminal of the electric component in a circuit. A, which is the positive terminal, and COM, which is the negative terminal. So it has two terminals, A and COM terminal. And the symbol of the ammeter is sorry, circle with a capital A inside it, showing the COM terminal. Now, how can I adjust the multimeter such that it functions as an ammeter? Below here there are three terminals. One of them we do not use it for now. There are two terminals, a COM terminal, the one to which the black wire is connected, and another one which has a label of V/A. So I connect this one is considered to be the positive terminal. Now how would it be acting as an A terminal of the ammeter? That is by adjusting the scale here within the range of ampere. As you can see here, there is an a DC showing DC current for in which the unit is ampere. So if the multimeter is adjusted within this range, then the multimeter will be acting as an ammeter, and this terminal represents a terminal. Now, an electric current is classified according to the direction of its flow and to the variation of its intensity. It could be a direct current or an alternating current. First type, direct current. Given that a battery allows the flow of direct electric current, answer the following questions to derive the definition of a direct electric current. So consider the adjacent circuit. An ammeter was connected in series with the lamp in order to measure the intensity of the flowing current at different instants. As you can see in the figure here, the COM terminal of the ammeter is connected to the negative terminal of the battery, while the other terminal of the ammeter is not directly connected to the other terminal of the battery. There is another electric component in between. So that's why we consider the ammeter to be connected in series. Now note that the COM terminal is connected to the negative terminal of the battery. The values were recorded in the table below. Okay, and here I'm showing each symbol corresponds to what? A for ammeter, V for voltmeter, and L for the lamp. So the values indicated by the ammeter are recorded in the following table. After 0.5 minutes from the beginning of the experiment, the ammeter was indicating 2.52 milliampere. Then after 1 minute, 2.5, after 1.5, 2.49, after 2 minutes, 2.51, and after 3 minutes, 2.5. So now how can we represent this using a graph? Convert the above table into a graph form. The appropriate scale is 1 centimeter for 1 milliampere on the y-axis and 1 centimeter for 0.5 minutes on the time axis. So when we take this scale, when we consider this scale for the y-axis, we can see that there is not the difference between 2.52 and 2.5 is 0.02, which is not really clear on the graph because the scale is much greater than it. So this difference is normal because we have some error that takes place in an experiment. Now we can consider this to be theoretically equal. We can consider theoretically that the current here is remaining constant because it's like fluctuating nearly above 2.5 or nearly below it. So approximately it's 2.5. So as you can see here, if you join all the points at different instants, they form a horizontal straight line, which means that it is constant with respect to time. So analyzing the obtained graph, then deduce the definition of a direct current. As time passes, the intensity of the direct current flowing through the lamp remained constant, plus 2.5 milliampere. So what can we conclude? We were given that the battery provides a direct electric current, and this experiment was performed. So now what can I conclude concerning the direct electric current? Direct current is an electric current that flows in one direction. This is one point, through a closed circuit with the same intensity. This is the second point as time passes. So the first point is same direction. The second point is same intensity. Now, same intensity, it's clear because we said 2.52, 2.5, 2.49 are almost the same. Okay. Now, what about the same direction? How did we tell that the direction is constant? This is because the sign of the values was the same for at all instances. In other words, because the indicated current was always positive at different instants. That's why we could conclude that the direction is constant, is the same. Now, if we reverse the terminals of the ammeter, like the terminals of the ammeter are reversed as shown in the adjacent figure. So the COM terminal now is no more connected directly to the battery, to the negative terminal of the battery. Now we have that the A terminal is connected to the negative terminal of the battery. So what happens? The following results are obtained and they are recorded in a table. Again, you can notice that the absolute value of the current almost remained the same, 2.5, 2.49, 2.52, all fluctuating around 2.5. But now concerning the sign, it changed from being positive to being negative. But though it changed from being positive to being negative, now for the whole time it's remaining negative. It's not fluctuating between positive and negative values. It's keeping the same sign as time passes. Does this confirm the previous conclusion? Yes, the results here confirm the derived definition. The results here confirm that the intensity, that the absolute value of the current or the intensity remains the same and that the direction remains the same. The direction here is considered to be the same because all the values have the same sign, which is negative. We obtained negative values because the ammeter's connection was reversed. That's why. Because the COM terminal is no more connected to the negative terminal of the battery. So the absolute value of the intensity of the current remained constant, 2.5 milliampere. Similarly, all the recorded values carried one sign, which is the negative sign, which indicates one directional flow with respect to time. So this is a summary. A DC, which is the abbreviation of direct current. A DC current is a current that does not change direction and intensity as time passes. So the graph represents the constant intensity, and the figure style shows that the current is flowing in the same direction.